Morning folks, I'm Dave Canterbury with Self-Reliance Outfitters in the Pathfinder School. What I'd like to do this morning in the cabin series is discuss a little bit more with you about self-mapping. I think that navigation, and in particularly mapping, making maps yourself, is probably one of the most underrated skills in bushcraft today. Your ability to go into an area that's unknown to you, explore that area, and look at that area for resources, and then be able to map that area, not only to get back where you came from quickly instead of having to backtrack, but also for future reference in case you are traveling with a party and you want to show them on a map where something's at, in case you want to know the straight line distance to something from your current location without having to go to several different waypoints on the way there. All of these things are reasons to make maps. The other thing to understand is that when you buy a map, a paper map of an area, it's going to be what I would consider a very large scale map. Even if you buy something that is as small scale, I would say, as 1 to 10,000, which means 1 inch on the map equals 10,000 inches on the ground. Even that is not going to be a very good map for you for things like trapping and hunting, other than an overview of the area to tell you what the terrain looks like and tell you where some possible main terrain features are. But as far as boots on the ground and telling you where that den is at, or where that turn in the creek's at that's got a good steep bank that you know you want to set for coon, or something that's got a deep undercut for a long distance you want to put 3 or 4 mink traps in along that way. You're not going to find that stuff, and you're not going to be able to go back to that stuff on a large scale map. But to be able to make a small map, you can put all the detail you want in it because you are the one making that map. And I did a video a while ago on self-mapping using a method called the Paul method. It's a very broad overview video of how to find your way back to your starting location without having to backtrack all the way. It also goes into a little bit of being able to add things into that map as you are in an area longer. What I want to do today is I want to expand on that a little bit, and I want to show you how to do things like what we're going to do in this video, which is, let's say that we have mapped an area out, and we'll start with a very small scale map from the cabin. And we found a creek that we want to trap, just like the creek we're trapping now. And what we want to do is we want to map that creek so that we can actually see it after the fact on a piece of paper and understand how to tell someone where to go back to each of our individual traps. Now, that could be as easy as just being able to give them the azimuth from the cabin to the trap and the known distance. That would give them a dead reckoning way to find your trap, but they'd probably have to bust a lot of brush to do that. If you can give them a map that possibly has some type of a handrail on it, like the pipeline that we're trapping off of, you can give them a much easier way to get to those traps. And if you can accurately map that creek, then you can show them where every turn and bend is in that creek along the way, and anywhere that that creek crosses their path as they're walking, so that they know they may have to avoid those areas, or how to avoid those areas, or where to cross those areas. So you can just draw squiggly lines on a map and say that's a creek, or you can actually understand exactly what every bend and turn in that creek does, and you can map that. And I'm going to show you how to do that today. Stay with me. Okay, I'm going to try to kind of shoot this over the shoulder and do the best I can to show you what I'm doing as I do it. What I've done is I've started with my log journal here. Very simple. We talked about this log in the first video I did on self-mapping. And so we've got 4 points on here where we have taken points from our camp out to the creek area that we're trapping now. And this is where it becomes important if we're going to try to actually map that creek. We can actually go down the creek and we can go from one trap to the next trap to the next trap, and we can mark those different distances and azimuths, and that will tell us where the traps are at. But it's not going to show us what the creek looks like or where the bends and turns and crosses are if we're going back out there. So that's kind of what we want to look at today. So what I've done on this map is I've transferred these markings onto this piece of paper to make a map, which is just a gridded piece of paper. And I have started off by orientating the top of the map to north. I've put my scale on here of 1 square equals 25 meters. And I've marked a starting point of the cabin here, and then 1, 2, 3, 4 points. And right here is the first point that's really interesting to us, because this is really where we're going to start our mapping. And this was an area where a creek that comes from back here comes up and turns, and it crosses this pipeline. And the pipeline really begins right here, goes up to a creek crossing, and then extends straight out. So what we want to do right now is, for this demonstration, forget about where our traps are at right now. We can add that information later. What we want to do is map the creek itself. And I want to show you how to do that. So a known point that we can always go back to is going to be where that creek crosses the pipeline. That's our last known point of origin, per se. So what we've done is we've marked that as a location. And then, because we have a pipeline, we have a very good handrail, but we still need to use an azimuth reading. So we've taken an azimuth standing on that crossing, or on the other side of it, straight down the pipeline, and we've correlated that here in our notes. We were at the creek crossing, we took a 355-degree azimuth for 200 meters, and that was marker 1. Now, because we're using a straight line, which is what we have to create, we really want to create some type of straight line to base the rest of our equation off of. So we've made a 200-meter straight line here, and we have a marker that we've put in place out on the pipeline. And that can be a stick with an orange bandana tied around it for sake of purpose, something like that. It can be a stick out there that has one of these yellow-orange strap ties tied around. And I use these a lot when I'm doing mapping because they're very convenient. You can just tie them on a stick and you can see them from a long distance. A couple things that you're going to want while you're doing this are an orange bandana, like we talked about in the first series of videos. And again, I would say that these strap ties are a good investment too. You can buy a package of them like this for like $1 at the dollar store, places like that. Just get some high visibility color that you're going to see at a distance so that you know where it's at. All right. The next thing that I like to use is just this circular protractor, and I've just put a piece of bright colored string through that protractor that I can see, just spin it around underneath the protractor. What this is going to do for me is it's going to keep me from coming back to the cabin and laying my compass on the map and trying to turn my compass to figure out all these different azimuths that I've written down in my log. I'll use the compass out on the line to do all of my stuff, to do my logging. And then when I come back, I can use this to go for my journal. Some type of straight edge is always a good idea. If you know that you're not going to be making straight lines on a piece of grid paper, but each one of these squares equals 25 meters, you want another piece of paper, and I just happen to have these two pieces of paper match up. This Write in the Rain notebook and this gridded paper match up. So I can use this straight edge to tell me that each one of these increments is 25 meters. So that in case I'm not at a full square or in the middle of a square, I'm taking out the corner of a square, there's no guesswork there. I can lay this down on the paper and go 25, 50, 75, 100 and know exactly how far everything is and that my lines are long enough the way they need to be. All right? So, okay, so how does this relate and why does this make things easy? The way this relates is when I go back to draw this out, I look at my log and I say, okay, from camp, I took a 75-degree bearing and I went 75 meters to a hilltop with a large pine. So I took my compass out, I took my bearing off in the distance to an object I wasn't going to lose sight of, and I walked 75 meters to that hilltop with the large pine. Now I can take this and lay it on my map, just like this, with the north pointed up and the crosshairs on the place I started. I can take a 70-degree bearing, just like this, 75-degree bearing, excuse me, just like this, dial that string into 75. I can make a mark out here on the edge of the string somewhere, and then I can come back with my straight edge and figure out how far I need to make that dot. 1, 2, 3, put a dot on the paper, come back in with a hard straight edge of some kind, and add that line. That's my first leg. So this allowed me to do all of that very quickly without having to mess around with the compass. And I think that's important. These things are very, very cheap. I'm not sure if we've got these on our website right now or not. This is a Westcott. I know you can buy these on Amazon for a fact, and they're very cheap, a couple bucks. And they will make a lot of difference in what you're doing and your accuracy level. Okay, so now let's go back to where we stand. We just drew a faint line on here, a phantom line, so that we knew when we came back that there was a creek crossing there. All right? So what we want to do for right now is we want to go back out to this area. And then we want to start about 25 meters up, or 1 square, or we could go 100 meters, whatever we decide. How accurate we make this creek is going to be depicted really by how many readings we take along this straight linear line. Because those readings are going to go directly to the creek, this direction, and each one of those distances then is going to correlate to a dot that's going to become a connected line and become the creek. And we can do that just where our traps are at, or we can do it in between, depending on how far our traps are apart and depending on what we want to do. So now we would take a separate log sheet and we would go out and we would say, okay, we're going to go up, so let's say 50 meters. So we're going to start right here. I'll just put an X right there for now on the paper so you can see where we're starting. My pencil will work for me. We're going to start right there, all right? And hopefully you guys can see this. I'm going to try to scoot this camera up just a little bit for you. I kind of got it hanging out the door of the cabin here. It's kind of a pain. Okay. I've got to adjust it in. So now we're going to go up, like I said, about 50 meters from our beginning point. And we're going to shoot an azimuth to the creek. So what we want to do is we want to first mark this spot, just like we do any other time when we're self-mapping. So we're going to take a stick and shove it in the ground, and we're going to tie our orange bandana on that stick, because then we can go anywhere we want to and go back to a known point of origin. So once we do that, we can walk our way in here until we find the creek. Once we do that, we're going to tie something on there, on a limb hanging over the creek, whatever the case may be, a stick right beside the creek, something on the edge. If we have to put a pole in the ground, we can do that. And then we will either tie another orange bandana, which there's nothing wrong with that, carrying 2 of those, or something like a zip tie for future reference. And we're going to zip tie it right to one of the limbs. Then we're going to go back and we're going to figure out what the distance and direction is from here to here. All right? Okay, so once we've done all this tagging, and remember, and pace counting, we're not carrying this with us. We're carrying our log sheet with us. So we're going to write on our log sheet that we went up 50 meters, and that's where our first tag is going to be. From there, we took an azimuth that we're going to take after the fact. Okay, we're going to figure out what this azimuth is after the fact. The first thing we're going to do is locate the creek. Leave a mark at our original spot. Leave a marker on the creek. Go back. Get a visual on that marker. So we want to make sure that we can see these 2 markers from each other. Get a visual on this marker and take a bearing with our compass. All right. So for sake of this discussion, we're going to say that bearing was almost directly west, so 270 degrees at 65 meters. And if you look at what I wrote on here, this is about 25, 50 and a half again. So right in the 65 meter mark, okay? And that's our first point. And we're going to go through and we're going to do that with each one of these. And our next point, you know, we may go up 50 meters again. We may walk up another 50 meters and put a mark. And this time, the creek might only be this far away. And the next time it might be this far away. And the next time it might be right here. And the next time it might be right here. And what that's going to allow you to do is, when you come back in here, you're going to connect the dots like this. And it's going to give you actually what that creek looks like as it flows through the area. All right? And that's important, because that's going to give you a lot more accurate picture of what you're looking at. Because you may want to know what's going on right in this area where there's a deep bend in the creek. Why is that deep bend there? Is it just something natural, or is there an obstruction there, like some kind of an old beaver dam or a muskrat den or something like that? There could be a lot of reasons for that. It could be a large tree right there that the creek has meandered around over time, or a large rock. But all of these things and doing things like this will allow you to get a very good picture in the end of the area that you're operating in.